Hi, I'm Annie Schatz. I'm a PhD student at the Virginia Institute of Marine Science. My research focuses on how climate change is affecting the physiology of larval and juvenile oysters in the Chesapeake Bay. So my lesson plan for the Virginia Sea program, called Case of the Stressed Out Larva, was adapted from one of my experiments that actually looked at the effects of ocean acidification and ocean warming on larval oyster physiology using a bioenergetic framework. This lesson is designed for advanced biology and oceanography in-person classes, but can definitely be adapted for general biology, shorter class periods, and a virtual classroom by omitting part 3 and providing your students with the data instead of having them generate it. So the overall goal of this lesson is to have students hypothesize, calculate, graph, and critically analyze one of the 3 molecular measures pictured here, so total lipid, total protein, and total antioxidant, that will then be shared with the wider class in a jigsaw puzzle approach to the larger question of how ocean warming and acidification are affecting the health of oyster larvae. So to begin, students will be given all of the necessary background knowledge about climate change, specifically focusing on ocean acidification and warming, and how stress from the environment affects oysters, and what the bioenergetic framework is and kind of how to integrate it and use it. So after you've assigned each group to one of the 3 molecular measurements, students will first go through a hands-on activity to show them what my assay or my tests are actually measuring, which is just the total number of molecules within a tissue sample. So each group will get 3 cups like this, and you will have prepared them ahead of time. And these cups represent the 3 replicates that each treatment in my experiment has. And so the students will sort through these mixtures and they will count the different colored beans, which represent the molecules of interest within the greater tissue sample, which are the black beans. And they will write down that number, and when they're finished, they will record everything in table 3 and go through the rest of section 1 to get a final total molecule abundance for that treatment. So this next portion of the lesson is the part that can be omitted for time or class level. But in this section, the students will use this microplate layout, which just shows the students where each sample is on the microplate, and this absorbencies and attributes document, which provides an image of the microplate with the measured absorbencies in those rectangles on top of each cell. This document also has some important information for the calculations that they will be doing. And if you are going to omit this section, then this is the standard curve equation you'll want. If you want the students to generate the standard curve, make sure to remove this. So students will use these 2 documents to calculate their standard curve, which are here in these 2 red boxes, and they'll use that standard curve to then calculate the molecular concentration of interest from the absorbencies of each sample. They'll then ultimately be filling in these 2 tables, B and C, to get their final molecule concentration for each treatment that they will then graph in the next section. Once the students have finished their graphing and have their final results, they will present it to the wider class, either in a traditional presentation, or you can use a gallery walk. Then you'll have your final discussion about how ocean acidification and warming affected oyster larvae using the collective knowledge that they have found throughout the lesson. So I really hope you enjoy it.